Morning, everyone. Welcome to another Power Hour webinar presented by Novatech. My name is Brett Dojan. I am a member of Novatech Automation's sales engineer team. With me on this webinar is Jamie Larson, another sales engineer on our team. And for this Power Hour, we have a special guest who will be helping us with our presentation and demo. His name is Brad Fuqua. He is the product owner of outage management and GIS with MillSoft Utility Solutions. And our topic for today is multi-speak, and especially the SCADA integration with outage management systems. The things we'd like to talk about today, first off, regarding multi-speak and OMS, we'd like to give you a basic introduction to both. First, we will address briefly what is multi-speak, and we will address what is an outage management system. And after that, we will talk about integrating the Orion and SCADA with an outage management system. Now, following that, we will go into our typical online demonstration. Jamie will be showing you how to configure the multi-speak server module in NCD. Following that, we will have a live demonstration featuring both the Orion, but especially showing SCADA and interaction with MillSoft OMS. And you'll get to see quite a bit of MillSoft's outage management system at work as well. To conclude the webinar, we'll just close with a little bit more additional information, an additional OMS vendor, NISC, and an additional capability of multi-speak integration with Orion SCADA, the application of meter data management. With that said, let's go ahead and begin. First, to introduce multi-speak and outage management systems. What is multi-speak? So multi-speak is, and the wording on here, I'll point out certain aspects of it. It is an industry-wide standard. In our speaking about it, sometimes we'll refer to it as a protocol. Mainly that's just because the way we configure it and the way that we at Novatech are used to working with it, it's similar in function to our protocols that we configure. So if we accidentally call it protocol, you'll know what we mean. Technically, it is a standard. It's developed and maintained by the NRECA. Many of you guys know them. They're the Rural Electric Association. And this multi-speak allows software products from different suppliers or vendors to interoperate, meaning they can interact with each other, they can send data back and forth without the need for building a big custom interface that allows them to operate. This is a simple means for that communication to happen. Regarding the multi-speak spec itself, it covers 40 of what they call functional endpoints. And you'll see this graphic on the screen is what they call the web services bus. And you'll see all sorts of different functions that a utility may need. And all these pieces fit together through the multi-speak standard. Now, how does Novatech fit into the picture? As you can see, we satisfy the SCADA portion of this web services bus, and we'll go deeper into that as we continue. But suffice to say for now, regarding multi-speak, has 40 functional endpoints, and it's currently in use by over 800 electric co-ops, IOUs, and municipal utilities. So the next step here, the rest of this webinar will focus especially an outage management system. So first, let's define that. That is a solution. It's typically software-based, and it's used by utilities to basically do everything involving outages on their system. It can detect outages, it can receive outage notifications, it can take outages, then analyze, you can monitor the outages, modify the outages, and you can ultimately resolve them using this system. And you'll see throughout the webinar, as if you recall from the web services bus, there's all these kind of hexagons that point out various kind of modules that interact with each other. And you'll notice I'll point out, you'll see these hexagons throughout my presentation. And this is just a reminder to you that this is a part of that web services bus, and just various features that a utility may need. And we'll show how interaction between these solutions in OMS or SCADA, how they take place, what's involved. So first, regarding an OMS, there are really two types of an OMS, or two different categories, I guess. You have a standalone application, The big players in standalone OMS in our talks with our customers, we hear the name MillSoft quite a bit. We also hear the name NISC. Those two companies are as I understand it, they're most of the market. Again, based on our interaction with our customers on the topic. There are other standalone OMS vendors out there. There are a few others. There are quite a few, probably too many to mention. But we hear about other vendors really only occasionally. But you should know that they do exist. They are out there. The alternative to a standalone OMS system are your OMS type, your outage management features that are built into a more fully featured SCADA system. And those tools would typically be built into a distribution management system, or DMS, or also an advanced DMS is also a term the industry uses, or ADMS. Now, with that said, since we've defined a standalone OMS, and then we've defined OMS functionality in a larger SCADA system, I'd like to put on just a short survey. I would just like to get some input on current use of OMS. So you should be seeing that on your screen now. I would like you to respond if you can. I'll leave this up for just a minute. And I'd like to know if you currently have an OMS system, or perhaps if you don't, if you're planning to deploy one, or if maybe that's something you're not looking at. So I'll let this go for just a little bit. Yeah, we're getting fairly good responses, guys. Initially, I will tell you, it looks like about 2/3 of the users on this call, actually a little bit more than that, they appear to have an OMS system. Let this run a little bit longer, but we do have good data, guys. Thanks for responding. I'll go ahead and close it in 5 seconds here. Okay. So based on the feedback we got here, it looks like about 40% of the users on this call have a standalone OMS system, and about 25% have an OMS as part of a larger SCADA system, like I said, an ADMS or DMS. And looks like roughly 35%, probably about 15%, it's something they're considering, and about 20% are not looking at an OMS solution, which is perfectly fine. And guys, thank you for responding. Let's make sure we're on the right screen here. Okay, so let's go a little bit deeper into an outage management system. What does an OMS do? The first thing an OMS does, it collects outage reports, and it does that via customer-initiated outage reporting. Now, when I say that, I really mean the old-fashioned way, right? Customers, maybe you'll call a utility, maybe the old-fashioned way, there's someone sitting at the utility answering the phone, or if it's over the weekend, maybe somebody has an outage phone with them. That was kind of the old way of doing things. There are more automated systems. There's the system where a customer calls into this number, reports it, and it's a bit more automated, including the solution that the industry likes to call IVR, or Interactive Voice Response, I believe is that acronym. So if you have an AMI system, a feature of AMI meters is there's maybe a small battery or maybe a capacitor in those meters that if the meter would ever lose its input, its source, it has just enough juice in that meter to send a transmission that we refer to as a last gasp that sends a notification that that meter lost its source. That's fairly useful to indicating meters that have lost power. And then lastly, the purposes of our SCADA. SCADA can send breaker, switch, recloser, status indications that can provide data to an OMS. An OMS then takes that data and it predicts an outage, including like the scope or the size of an outage, and that includes the count of affected customers. And then it will, it will display information about those outages on the screen in the software. Now, in that software also, users are able to track outages, they can document, they can add details to an outage, and they can also assign crews. So all the way up to, they can edit it, up to and through restoration of that outage. So after restoration, the OMS system holds on to those that outage data, those outage records, And then when the time comes to report data on outages or maybe just general reliability statistics, that becomes a very, very easy process since you have all the customer outages here in one place. So I made reference that the OMS predicts outages. So how does it do that? So the OMS has an outage prediction algorithm, and that algorithm typically is based, for the algorithm to work properly, it needs to know where meters are on the system, both in relation to other neighboring meters and in relation to protective devices. Now, when I say protective devices, typically I mean anything that will open or close the line, typically in response to an outage. So that can be reclosers, it can be breakers. Technically, for the purposes of the OMS algorithm, that could include, fused cutouts as well. Now, typically those aren't going to be connected to SCADA, but that is the OMS algorithm can predict, to a device like that as well. So the GIS model, it's important you'll need to create a GIS model, and of course, as you make updates or upgrades on your line, you'll need to maintain that model to include all the devices on the distribution system for the utility. Now, with that model, that's what provides the hierarchy. So then OMS knows where everything's located, and that, of course, allows the algorithm to do what it does. A little bit deeper into prediction. So the OMS collects outage reports. I have mentioned that on the previous slide. The OMS then, that data that comes in gets translated to the meters that are affected. And it takes the meters that are affected and tries to group the meters together under a common protective device that'll determine the scope of that outage. So once that prediction's made, the user can edit any details of that outage, including if the algorithm, let's say, does not work 100% properly. Maybe it includes some meters that it believes is affected, but they really are not. You can make full modifications to that outage. You can pluck certain meters out of an outage, or you can create, maybe if there's an extra, maybe a fault event, maybe within the predicted scope of an outage, maybe you have 2 devices that were taken out. You can reflect that through your editing the outage in OMS as well. But in the case of, say, a utility is planning some line work, something, that of course won't be an active kind of unpredictable type outage, but some work that they've been planning, something they know is coming, you can enter an outage manually. That's fairly commonly done as well, and that's another useful feature of an OMS. So let's chat about the Orion. Let's chat about SCADA and how we integrate that with an OMS system. So some advantages of SCADA integration. Now, what does it allow to happen? What it boils down to is that SCADA can send real-time unsolicited data value changes into an outage management system, and vice versa, two-way communication. The OMS can request point values, or really it can even request the whole point list itself from SCADA. So, we can send the whole point list, which makes assigning points to that GIS model, or to that kind of hierarchy of devices, it simplifies it quite a bit. But the result of this two-way communicating, which includes SCADA points, it results in improved outage prediction, because if you have a decent-sized group of customers out of power, there was probably a breaker or recloser or something that SCADA does monitor that was the device that opened up for that outage. If so, then you can have you can have accurate prediction, because obviously the people downstream from that device, they're probably out of power, barring some sort of more complicated protection scheme. You can have verification of outage events and restoration. That's just simply through, if a device opened up, that's typically the starting point of the outage, and when that device gets closed in, that would indicate the moment restoration took place, and you can have extra data in your OMS or in your outage records that tells you when a breaker opened or when it closed in, which would then serve as kind of a verification that actually happened per your SCADA system. So it's greater for accuracy in outage reporting also, because for outages that the operating device or the protected device was a breaker or something SCADA is monitoring, suddenly we have exact timestamps of when that outage began and ended. Whereas the old-fashioned way, if you're relying on outage calls, you're not certain when the outage actually happened, and you're forced to rely on either guessing or assuming that the outage started when the first call came in, which typically, there'd probably be a few minutes delay before you would get your first outage call in. Greater accuracy in reporting too, once again, due to the breakers, showing exact times they open and closed, you get pinpoint accurate reporting. And finally, something we've not mentioned yet, you can bring analog values in also. Let's say you want to bring currents in, maybe for engineering analysis. Let's say if your OMS solution also has an engineering analysis section of it. In the case of MillSoft, who we have on our call today, they have their analysis software, and maybe some other providers do too. But you can pull in maybe currents. If you're trying to analyze a fault, you could bring in fault currents, and you can do analysis based on that, including, you could do fault location if you have access to that. Maybe a circuit model for engineering analysis. You can do that sort of analysis in there too. So it adds quite a bit of usefulness. So the integration process, the steps involved, and Jamie will go through a lot of this in detail here in just a few minutes. But first, you configure multi-speak in NCD. You configure a multi-speak server module. That's actually a network, one of our network protocol choices. You just make the basic setup configuration. You include the points that you want to send, and then you will send that NCD file to the Orion. On the web interface, the only thing you really need to do besides sending the files, you need to enable the multi-speak listening ports for either HTTP or the more secure HTTPS. Once you've done that, there are a few things you want to configure in the OMS software, for the other side of this communication stream. You'll want to verify that the communication initiates successfully. You can view the comms in the web UI. Jamie will show that too. Once that's all confirmed, once we have two-way communication, you can proceed to link points into the system model, and then you can finish configuration on the OMS side. This is the critical screen that you'll need to set up in NCD. I wanted to run through it really quick, and this is mainly just to ensure, if there's any confusion that happens during the setup process from the SCADA side, it's typically this screen. So I wanted to point out the description, just like any of our other protocol modules, you just give that a name that makes sense. And then you'll see the multi-speak version. You can select a version 3.0 or 4.1. About those, I can tell you 3.0 came out in the year 2010. 4.1 came out in 2015. 4.1 kind of superseded 3.0, but occasionally you might see a 3.0 multi-speak out there, which is why we do have it available for our customers. I will tell you 4.1 I think is a lot more common. In fact, I don't believe I have seen a case to this point of multi-speak 3.0, though it is there. As far as this first user ID and password, to be clear on these are credentials that the OMS will send to the Orion. And there's nothing additional you need to do other than populating these fields, because these fields, of course, the NCD file going to the Orion will tell the Orion, that these are the proper user ID and password. So then it just checks to make sure that these credentials are what the OMS sends. Vice versa, the remote user ID and password are the credentials the Orion sends to OMS. So on the OMS side, somewhere in setting up this multi-speak communication, you'll need to make sure that this user ID and password are there, and as important, making sure they match. This request IP address, when the OMS sends messages to the Orion, the originating, it's going to come from a specific IP address, and we need to populate that IP address into this field. And when the messages are coming in, it's going to make sure that the originating IP address is what we say it's going to be. So it's critically important that this IP address is correct. Regarding the notification endpoint, there's an endpoint on the SCADA side, there's an endpoint on the OMS side. So this address that goes in this field is the address of the OMS's SOAP server. I'll go more into SOAP in just a moment. The Orion sends messages to the OMS at this address. And if you look at the top of this slide, the endpoint URL for the Orion's SOAP server, it is a standard address across our Orions. You'll see we need the Orion's IP address. Now, typically this OMS is going to be on your utility server, so you'll just need its network IP, and you will give it a port number also and that's defined if you're using HTTP, that is port 8080. If you're using HTTPS, that port is 8443. And I guess worth mentioning, if you choose to use HTTPS, of course, it's a secure connection. You will have to go through that process like other secure protocols where, you have to do that kind of certificate exchange, that kind of authenticating process, like you would for other protocols. You have to do the same here, or other devices, let's say, on a secure network. Finally, the buffer and the queue size, those are things typically I think are best left alone unless you have a reason for changing it. And then lastly, down there, you see the option that says notify only latest analog changes. So based on the settings on this screen, the buffer timer you see is set to 5,000 milliseconds or 5 seconds. It's going to check and it's going to send analog changes every 5 seconds. Now, if a specific analog point has multiple changes during that time period, if you check this box, it's going to send only the latest change for that analog point instead of sending a whole bundle of changes that occurred over that period. So that can be useful in some cases. Let's say if you have a lot of analogs, or maybe analogs that tend to go through frequent changes, depending on what you're sending over. Lastly, the time zone, you can set it to use either local time or UTC. It's just a simple drop down. It's, you select from those two choices, depending on what you'd like Multispeak to use time-wise. So I mentioned SOAP. It stands for Simple Object Access Protocol. It's, I guess, what the computing world refers to as an API, or an application programming interface. What we need to know, the kind of lay definition for our purposes. SOAP is a protocol for exchanging information between applications. So exactly, what we're doing between our SCADA application and an OMS. And it uses XML as its kind of messaging technology. SOAP, as a lot of things, were developed by Microsoft, probably worth noting. So let's give you an example of a communication through XML or through SOAP. You will see this. The communication stream like this is exactly what you'll see on startup if you go into our view comms on our Orion Web UI, or if you go through our terminal also, you'll see this same stream. So this communication, if you look at it on the Orion, we do a good job of including these kind of log messages so you know exactly what is happening. You'll see right here about the first thing we do is we do a ping URL, which basically we're pinging for a response from the OMS system. And this kind of SOAP action, this says exactly what we're doing. And we'll send the credentials with it. You'll see right here, we have the user ID and the password, and that's used for authentication when you're sending the message. That's sent along with the message. Now, MuleSoft's response to this, you can see, and one thing I failed to point out, TX is just what it says at the beginning if we're sending a message. RX is the message that appears if we are receiving a message. So there are several ways that this response starts. We are showing 200, which indicates OK, which means that this request was successful. Always a good thing. And then you'll continue on, a lot of information here, a little bit of kind of identifying information. The response, I believe, is right here where you see this kind of ping URL result. This information right here is the message it's sending, which is basically just confirming or responding to that ping. And then you see the note at the bottom. The Orion message says that the ping URL was successfully retrieved. This is just to look at how that works. So first, when we're doing initial connecting, the ping URL is sent, and after that response, it sends a method called get methods, or a method is just essentially just a request or kind of an action that it's taking. So then your OMS, it responds by sending a valid list of method names back. And then, when we send additional messages, it'll be similarly sent by XML. It'll look just like it did on the previous slides. Now, when it comes to this communication between a SCADA and an OMS, these are some of the common methods that are used. You'll see we showed ping URL. We talked about get methods. And these status, these names of methods pretty much say what they are. There's getting all SCADA points, which is just a list of points that we can send to OMS. OMS can request points using this get SCADA status and get SCADA analog by SCADA point ID. It can request specific points and their values. And then the Orion unsolicited can send status change notifications or analog change notifications. At the moment those points change, it can use those methods to send the data across. With that said, that I think is a good enough info to OMS and the Orion, at least as far as slides can go. So at this time, I would like to turn it over to Jamie. Jamie, are you ready for your portion? Would you like to show setup?
Let me know when you see my NCD screen.
I see it.
Okay, great. Good morning, everybody. So as Brett mentioned, the live demonstration will happen kind of in two parts. I'm going to step through how to configure the multi-speak module in NCD and how to get that into your Orion and communicating with the OMS side. And with the points that we configure to be sent through multi-speak, Brad is going to show some simulated outages in the MillSoft software and how you can resolve those outages using the SCADA data points. I've taken the liberty of doing a little bit of legwork on this NCD file already. What I've done is I've configured one DNP client port. This device is manufacturer agnostic. All I did was create some very simple inputs, both binaries and analogs. And the one thing to note here is we've got breakers 1 through 5 status points and then 3-phase currents for all of those breakers. So these are the points that Brad's actually going to be using in his MillSoft demonstration. So just keep in mind that we've got 5 breakers mapped over this multi-speak port. So once we've got this device completed, how do we get that over to our OMS system? We're going to create a new network port, keeping in mind the multi-speak is network only. Scroll through our protocol list. And as Brett had mentioned, multi-speak 4.1 is kind of the new standard. It's got things like enhanced messaging, expanded web services, some more functional areas like integration with advanced metering infrastructure, distributed energy resources. So while 3.0 might still be out there for new applications, we're always going to go with 4.1. So this first port screen that pops up, all you need to do is give your port a recognizable name. For our purposes, multi-speak server will work just fine. You'll see this module name, which is defaulted. There's a different module name for multi-speak 3.0, but this is not editable. Then the rest of these fields down here on the port page, this is for setting up a proxy server. So in the case that you're running an OMS system that is not on your network, you may want to use a proxy server, which essentially acts as a web gateway. We're not going to use one today. So we're going to uncheck use proxy. If you were to use it, you simply enter the IP address of the proxy here, the port on that proxy server that's going to be listening, and then the user credentials and the SOAP version. But for today, we'll just give our port name something recognizable. We'll hit accept. And then we'll add a new RTU. This is the screen that Brett went over in detail, so I won't spend too much time. All I'm going to do is give this, again, a recognizable description. The user ID and password here, these, again, are the credentials that OMS is going to send to the Orion. And the remote user ID and remote password are the credentials that the Orion is going to send to OMS. The request IP address is the OMS system, the originating place where the messages are coming into the Orion. So I'm going to put in the IP address of Brad's OMS server. Notification endpoint, this is the URL that the Orion's messages are going to land on. So broken up into parts, it's HTTP / and then the IP address of the server hosting the endpoint, which is 12.218.155.155, followed by the port number, 16499. And then lastly, you're going to put in the specific path on the server that identifies the service that's going to be accessed. So in this case, it is 416/soap/server. And then you've got some more communication parameters down here that we'll leave as default. So we'll hit accept and update the RTU. And on the inputs list, we'll filter by that DNP client that we had made, and we'll select all of our breaker statuses and breaker currents, map it over. We'll hit save, and at that point, you've got your configuration file ready to be uploaded with the multi-speak module configured. So I'll come to my Orion SX. You can see up here, we've got our MuleSoft test file. This is the same file that we already created with established connections to Brad's OMS system. So I will show you real quick the view comms on the multi-speak server. So this is usually you'll just see the analogs and statuses kind of updating or not updating based on, yeah, here you go. No analog changes sent to multi-speak. Basically, it's in a steady state, it's connected, it's ready to send data if anything were to change. The last item I want to show you in the web UI, when you have a configuration file uploaded to your Orion that's using multi-speak, this is what Brett had mentioned earlier. You need to enable the listening port for HTTP or HTTPS and make sure that you hit save down here. So now that we've got everything set up from the Orion's point of view, I'm going to hand it over to Brad so that he can continue our live demo in MuleSoft.
Okay, great. I'm going to share my screen here. Okay, I believe you should be seeing my dispatch outage management system. Let me first of all just start off and say thank you to Novatech for inviting us to be a part of this webinar today. We're excited to be able to show off the functionality in a live demo. We have been integrating with various systems, whether it's AMI, SCADA, AVL, customer billing systems with multi-speak for many, many years. In fact, I went back and looked. I think we actually started our first or tested our first compliant SCADA integration with our dispatch outage management system back in 2006 in multi-speak 3, the first version. So this is a well-worn path that we're demonstrating today. I just want everyone to know that this is something we've got deployed at many, many utilities across the U.S. and we're excited to have this capability. It really does make OMS much more useful and really makes managing outages easier. So just a quick tour here. This is our dispatch screen, and as you heard Brett earlier describe, we do have the full detailed circuit model that you might have used before if you're an engineer, if maybe you're familiar with Windmill, our engineering product, where we create and modify our circuit model. And so every transformer, every fuse, every consumer, every conductor, all with the correct engineering definitions, right? This is 4 ACSR on this conductor. I can see my voltages, my impedance links, everything should be defined as accurately as possible to make the system work. So our OMS system, we interact with this model. We also have a tabular view of data, and we'll be kind of looking at both screens. Typically, we would set the tabular view on one screen and have the graphical view on another one side by side. Of course, that's difficult in the webinar, so you will see me going back and forth between the screens. But this is our dispatch client, and as Brett said, full management system from taking all of our inputs for our calls, our AMI meters, our text reports from members, all of that data coming in, predicting our outages based on the connectivity, that detailed connectivity model, and then giving us a full set of tools to manage the outage while it's happening and also report on the outage after it's over. And that reliability reporting, of course, is a very, very critical piece. And just by working the outage during the outage process, you're recording all the data we need to give you very accurate outage reporting. Okay, so let's dive in and specifically look at this configuration with Novatech. This is our service manager, and here we have what we call a multi-speak service. On the outbound tab of this multi-speak service, you can see we have configured an integration with Novatech Automation. I'll just bring up this interface editing screen where you can see, similar to what we saw on the Novatech side, we've got the ability to select our multi-speak version. We can choose what type of interface this is. This is our SCADA server, a company name, company ID. Here now is where I enter the correct URL for us to speak to the Novatech server and credentials, as you'd expect, HTTPS configuration. So all of those similar settings that you might have. Basically, when we go to do one of these integrations, we're gonna share that information back and forth. Once we think we've got things communicating, I do have the ability to come and test the interface. And so there you can see, as Brett described earlier, the first thing we did is we did a ping URL call and asked, hey, can we communicate with your server? We got a response back that was good. So then we immediately turned around and called a get methods. That get methods request, you can see then Novatech responded and said, here's the methods that we support that you can call against our server. So that's a live communication test between my server and the Novatech server that Brett and Jamie have set up. So once that's configured, the other real key component that Brett mentioned is mapping our various SCADA points to our GIS model. Now, the way that looks in our SCADA menu, I can bring up a screen that will let me request from Novatech the list of all of my SCADA points. So this is my SCADA point viewer, and you can see if I expand that out, maybe you can see a little better. Here we have all the various point IDs that Novatech passed across. I can see if they're status points or analog points. And in this last column, I can see if a particular point in the grid is mapped to a particular element in my GIS model. So we have to step through in the configuration and do this one-to-one setup, configuring which breakers, which OCRs in our model are mapped to a particular SCADA point. And you may have noticed that breaker 1103, it indicated that we had some SCADA points on it. So I'll just bring this particular feeder breaker up on the screen so we can take a look at it. We've got our substation here in yellow is that feeder breaker. And when I click on that, I can look at the SCADA tab and I can see that's configured as breaker 1 in my device statuses. And I can see I've got fault current points as well. I don't have any analog points configured on this device, but I do have device status and fault current points mapped from Novatech to my MuleSoft model. So we're going to step through a few outage scenarios and demonstrate the benefits. Hopefully you'll see those pretty clearly. We'll talk through the outages and what we're showing, but we're going to demonstrate a few different outage scenarios. This first one, we'll just assume we have a feeder operation. And so this breaker, this 1103 breaker that we've mapped point 1 to, is going to lock open. And when that happens, Novatech will send us that open. And Brett, if you want to fire that off now.
Yep, sending right now.
Perfect. Okay, so here's what happens. We haven't received any calls, right? Just within seconds of that breaker locking open, the SCADA system indicates that, sends across the interface that we had a breaker lock open, and you'll see the time is recorded, and we can see very clearly that this is a SCADA operation. Now, in our MuleSoft world of outage management, that came in as a verified open. I didn't jump into outage statuses yet, but outages go through various states. The first state, if we were to look at a different outage on the map here, you can see we took a couple of phone calls from members reporting themselves out of power. We've got a couple of phone symbols there on top of service locations that reported outages. And we predicted, 2 calls, different transformers, same phase. Our algorithm Brett was talking about has looked and said, okay, the most likely location is the upline fuse is blown. So we're gonna show that as the potential outage location. It's a predicted outage. And in our world, again, predicted is we think that's the right thing. We think that's the right location. We've got an open point. But a prediction is just that. It's a guess, right? The difference here, when the SCADA operation comes in, it is immediately a verified outage. We know from SCADA, this device is locked open. We know we have all 437 customers downline from this outage out of power. So if I'm a dispatcher, that gives me great confidence. Hey, we got to get somebody out there. And as Brett mentioned, we can assign crews. You know, we have a full crew management suite of tools. I'll just quickly drag and drop a crew onto this outage. And I'm going to bring up now the tabular view so we can kind of see side by side a couple of things. Number one, you know, we've got color coding in our system. They're going to help you realize and easily see those statuses like verified or predicted. I can see, you know, all of my timestamps that have come in. You know, here's a remark that gets automatically created when that crew assignment happens. I've got the ability to put in an estimated time of restoration. If a crew gets out there and tells me it's going to be a few hours before we get this outage restored, you know, I can easily come in and put in an estimated time of restoration of 2 o'clock. If I had integration with an IVR system where customers are calling or receiving text, you know, we would share that estimated time of restoration with those customers that call or report the outage. And the other great thing is there with our MillSoft IVR, if I'm the first caller after this SCADA operation happens, I'm going to be told immediately we're aware of the outage affecting your area already. So within seconds of that device locking open, we've got that in our OMS system, and we're giving customers better communication right off the bat when this outage starts. We also have outage viewers where we can share outages to the public and share status updates. I'm not going to demonstrate that today, but, you know, we've got a full suite of tools to let you manage this outage. So in this scenario, you know, we don't really know what the problem is, right? We've got a crew on the way, but one of the things Brett mentioned that we might want to do is leverage our SCADA system to help us find where this issue might be. And we might take advantage of the fault location abilities to do that. So I'm going to double click on this device again, looking at my SCADA tab. You'll see we've got our breaker status points, and we can see, we could read that status. But what we're really interested in now is using the fault analysis, the fault currents, to run a fault location. So I can read, by clicking that button, the current fault amp. So that was another multi-speak request. Our dispatch system made a request and said, can you give me the SCADA fault values by point ID? So we reached out and asked for the status, or the fault amps by these particular point IDs that I have mapped. And you can see we've got 1,250 fault amps on B phase, and here's our timestamp. So what this will let us do is run fault locator. And when I run fault locator, I'll just click the run button here. That's basically going to do a fault current analysis from that selected device downstream and try to identify where could we possibly have measured that fault value that we received back from SCADA. I'm going to zoom out there a little bit. So these results, you'll see, are just simply listed here. I'm currently using a model trace, and that's helpful when I'm looking at these results because the element that I've got selected is highlighted in yellow. Green is upline, going back towards my source. Everything blue is downline. So as I kind of look through these elements, I'll see that fault tracing highlighting, and it certainly looks like we've got a little cluster of elements right in this area here where that line splits and heads east and west. You know, that might be great information for me to send my crew. Why don't you start looking for that fault in this particular area? We've had customers give us great feedback on the accuracy of the fault locator tool and the results it provides. But of course, that is all dependent on their detailed circuit model being established in GIS correctly. We've got to have those correct definitions for each conductor. We've got to have the correct impedance values. We've got to have all that data underlying the system for this to work correctly. But we'll assume our crew gets out there. they find a problem, work through the outage. We might have sent some alerts or updates to customers along the way. Once the crew, clears that tree limb off the line or whatever it might be, and they radio back that we're all clear and we want to restore this outage, we'll have Brett now close that same breaker, and we'll see dispatch automatically receive that close and restore this event. And there it is. So when that came in, again, we can see very clearly from SCADA that this device is restored. We don't have any customers out of power. If I go back and look at this outage in our tabular view, I just want to also highlight, at any time I can come and look with this record selected and these sub-tabs. I've got lots of options. And one of the things I can see is the list of SCADA status events that were related to this particular outage. So I can see my time that we received the open, and I can see the time that we received the closed for that device. And I'll even be able to look and see all 437 customers that were affected. I can see their unique times of interruption and their unique times restored, and those timestamps are going to line up for that accurate outage reliability reporting. Okay, so there's our first scenario, real straightforward. We had an open, we ran a fault location, we sent a crew out, found a problem, got that restored, and then closed that back in on SCADA, and that data flowed across again to restore that outage. One of the things we've run into over the years, again, we've been doing SCADA integrations for a while, and one of the scenarios that became problematic in OMS that I just want to highlight is this scenario. We have an existing outage on a feeder. We've got, again, this is two customers have called in, and we have a predicted outage on a downline fuse. Now, when we first started with outage management and SCADA integrations, if we had a feeder operation on this same line, our prediction engine would basically take that downline fuse outage and roll it into the upline SCADA operation. And we would lose this downline fuse outage being there existing ahead or before the SCADA operation occurred. A couple of versions back in our software, we added some ability to change that, and I just want to demonstrate how this works now. So if you've seen our system before, this may be a new thing you haven't seen demonstrated. But basically, we're going to work a very similar outage. We're going to have a breaker open up, but what I want you to watch out for is what happens to this downline fuse outage. So Brett, we'll go ahead and open breaker 2. Okay, so
there we go.
We've now received an open here on verified open on this breaker. 177 customers are out of power. Again, we can clearly see that was from SCADA. And what happened is we have a setting in our system basically that's going to let us choose. Do we want to automatically verify an existing downline outage when we receive an open from SCADA? And we can even set a time here in seconds for how many seconds before the verification time did that outage need to exist before it, so that we can verify it. So if they came in really close together, we wouldn't, depending on that setting, we might roll them into one. But based on our settings here, this outage was definitely there 5 seconds before the SCADA operation came in. So we verified the existing fuse outage, locked it into place, and then verified open the breaker, taking out the other 177 customers. So now we might, again, send a crew out, work this outage. They might be able to restore this circuit breaker. So Brett will go ahead and restore breaker number 2. There it is. And just want to demonstrate, this outage has worked independently of this downline fuse outage. We don't lose that nested event that we have going on downline that was there before the feeder operated. So that was a good change many customers had asked for. Again, that's an optional setting in our system that can adjust the predictions. One other thing I didn't mention earlier, but it is probably worth mentioning now at this point, is that our default prediction engine setting is that if we define a device as having a SCADA device status point, we take this device out of our normal prediction routine, meaning we won't predict an outage to this feeder breaker when calls come in down line. By default, we're going to expect the SCADA integration to control and tell us when this device is open or closed. Now, if I have a different feeder that doesn't have SCADA configured, I won't have the point IDs, and we could take calls and enough outage reports to naturally have the prediction algorithm grow an outage upline to that feeder element. But once the SCADA device point is applied, we take that out of the prediction routine. Again, that's a configurable option. You can say, I want it to still predict to a feeder breaker, even if it has a SCADA point ID applied in the device status. But by default, we no longer predict to a SCADA device. Okay, so those are just a couple of scenarios. One other scenario we want to demonstrate, we are seeing more and more common is scenarios where we're getting SCADA devices downline that are being controlled. So, you know, when we first started working with SCADA integrations, it was very common to have every feeder breaker controlled by SCADA, but more and more regularly, we're seeing automated restoration schemes where we can have SCADA controlled devices further down the circuit. And that's really changing how SCADA integrations work with our system and how just a broader acceptance of SCADA in general, taking advantage of the technology. And so we wanted to try to demonstrate that as best we could. So the scenario we've got is we have another feeder breaker here, and I didn't mean to close that window. Let me type that number back in, 2805. So I'm going to highlight here the feeder breaker is in this cluster of elements. So as we look at this line, we're going to see, zoom out just a little more, we're going to see this feeder feeds down and there's a normally closed switch here. We feed a large area of consumers here that's active. And on the other end of that feed, we have a normally open switch. And so the scenario we're going to demonstrate is if we have an automated restoration scheme. So we have this breaker lock open. And the next thing we're going to see is that we're going to open automatically a normally closed switch, and we're going to then close the normally open switch, backfeeding a portion of these customers and automatically restoring a section of this outage. So I'll zoom in here just a little bit to try to make that really easier to see. And we will step through this next demonstration. So Brett, when you're ready, we're going to send an open on breaker 3, an open on the first switch. So there's our verified outage came in, 449 customers out of power. The next operation we're going to receive from SCADA is going to open the switch, isolating this large section of customers from the rest of this circuit. And you can see we received that there is a temp operation, a temp open. And the next operation is going to automatically close that upline switch. And when that occurs, you'll see our outage numbers, 449 customers out of power. When we receive the close command on that final switch, you're going to see that outage number change. There it is. So we've temporarily closed the switch on the north side there. That outage now is only affecting 5 customers. So we've only got 5 customers in this area that's highlighted in pink, 5 active service locations that are out of power. So this automatically restored this entire neighborhood here from the north side, backfeeding that circuit. Again, if I were to click and trace my circuit model out, I'll see this area now in blue is abnormally fed from this circuit to the north. And if I were to trace here on the line in pink that's out of power, I can see that ends now at this open. It is important to notice also just the fact that these are temporary events. So our verified outage came in. When we receive SCADA events downline from an existing verify, we're going to treat those as temporary operations. So we're temporarily backfeeding this area. So, sometimes I spent 8.5 years at a utility myself, and sometimes these temporary backfeed scenarios they become less temporary over time. We might backfeed an area, and the normal open point now has kind of moved to a different spot. And so we want to just close out this demonstration to show if we restore this breaker and get the remaining 5 customers on. And so Brett, you can go ahead and send that command over. There it is. So we have received a close command on this breaker. And I'm going to go back here to my outage manager screen. Again, we'll be able to see here's the records that came from SCADA into OMS in order. So here is our closed event on that element 2805. If we were to look at this edit outage details, we would see all of the various events from SCADA that came across. We would also be able to see again that 444 customers have one restore time that's really close here, right? 10:53:57 and 10:54:34. So, less than a minute of outage time, right? They weren't even really, didn't have a sustained interruption. But if we scroll down the 5 customers at the end, now we've got a different time that we recorded for those 5 customers that remained out of power for a longer time period. So just to demonstrate again, we are recording every unique service location's off and on times. And if we have multiple interruptions in one outage where people come on, go back off, come on, go back off, we're going to keep all of those timestamps stored so that we can give you very accurate outage reporting. And so now we'll assume, we've had this outage. We're going to just go ahead and assign some cause codes in our system so we can track our outage causes. And I'm just going to randomly pick a few codes here just to demonstrate this, but we'll assume we had a lightning event. And I'm going to close this outage out of the system. And when I do, that outage is removed off the map. But if this temporary switching that we applied is still there active, that can stay on the system as long as it's active in the field. And once we decide we're ready to put that feed back to normal, we'll be able to do that again and receive the commands from SCADA to restore this. So what you're going to notice, we're going to take the command on the open switch, setting it back to normally closed. And our system now is going to display an L. That's a loop switch, because at the moment, we haven't opened the north side. So we actually have power feeding from both directions. But when Brett sends that open command on the switch to the north, you'll see we're going to draw things as they normally are in the GIS, and we'll be back in our normal state, showing an open switch on the north and a normally closed switch here. And so now the outage is fully restored and everything's back to normal. Okay, so those are the 3 scenarios we just wanted to step through. I hope that was helpful to see the live integration, passing data back and forth. And at this point, I'll hand the presentation back over to Brett.
Okay, thank you. Thank you, Brad. Make sure I'm showing the right screen here. Yeah, should be. You guys, Jamie, Jamie or Brad, do you see my window?
SX.
Very good. All I wanted to point out was over the course of that demo, all I was doing was I was working through, here under data values, and under we had a DNP connection set up, and I was just manipulating these points by forcing points. Obviously, in practice, this thing in the field, those are going to be automatic. I think that's self-explanatory. I just wanted to show you what I was doing on my end behind the scenes to aid in that presentation. But again, we thank Brad for taking the time to run their OMS for us and give us a pretty good display while we were doing that demo. With that said, I'm going to go ahead and close out. Apologies, guys, up front. I know we're going to run a few minutes, probably about 5 minutes late, but I do appreciate you guys hanging on. So before we close out, I do need to mention, since we do, we have some customers that are using it. So I wanted to mention and I wanted to show a little bit from the OMS solution from NISC. One thing I should point out, whereas a lot of OMS systems, mostly MillSoft included, has the OMS typically hosted by a utility on the utility server, NISC does things a little bit differently. What they do is they typically will host the OMS, I guess, on the cloud or on their remote servers, which of course comes with its advantages to doing it that way. Of course, it has its pros and cons. One thing I did want to say, for our purposes, if you guys are setting up multi-speak to integrate between the Orion and NISC, you should keep in mind that this OMS solution, of course, being remotely hosted, the process of doing this integration, we will want to have NISC closely involved because it is going out across the web to this cloud. You will certainly want your utilities IT to be involved in the process, and just depending on the process here, any difficulties you all might have, you may also need to have Novatech involved too. So you would want to reach out to us in the case that you're having difficulties with this process. Just something I wanted to state from the outset for NISC. With that said, I'm going to jump in, just show a few of kind of the more tabular type data to just show how our SCADA integration can have a positive impact on their system, similar to MillSoft. You can see here, this is just their general outage manager screen. Shows a list of their active outages based on a certain number of outage calls or outage reports, and then the number of people out. Down here, you'll see kind of a record of these outages and their statuses. You will see this one here. This one is marked complete, and you'll show that the status, the outage number was in fact restored, and you'll see this extra column here showing that the restoration is based on a SCADA verified close. So that will also show on NISC's system. This is an example of an outage. This is kind of their outage modification screen, similar to what you showed, Brad opened up a few times on MillSoft's system. But this is kind of a practical example. You'll see at the bottom there are some comments. It shows kind of indications and changes that are made to the outage. You'll see that these timestamps at 2:19 p.m. SCADA reported the recloser open. So the Orion sent an open state for a breaker, which happened to be on this utility's Romo substation feeder 4. And one thing I forgot to mention, these screenshots were provided to us by one of our customers, a customer in Eastern Montana. And of course, we thank them for sending us this information and allowing us to use it. So again, thank you. So back to what I was saying, the breaker that is at the top of substation Romo sub feeder 4 went out. You'll see here, I want to draw attention to the tabs at the top of the screen where a phone call came in. So the way this was configured, SCADA indicated an open, but it seems the settings on NISC's OMS system, I'm sure it's customizable like MillSoft's is, but it waits to create an outage until a phone call came in. Once that phone call came in and it was under the Romo feeder 4, the algorithm then jumps the active protective device, the one that opened up. It knows that it was that Romo feeder 4 breaker. So you can see at that point, as soon as that phone call came in, that's when the outage got entered. Or, well, it says here it got entered by SCADA, but it was initiated by a phone call. And that's just the way they had it configured on their end. Shortly after, you'll see that SCADA reported the recloser is now closed. And that was due, and really hearing from the customer, that is due to the customer use the Orion's, the HMI, to do a close of that breaker. And as you can see, it closed in and it's holding. And you can add kind of custom comments. You can add kind of text comments. You can do the same on MillSoft. You can do it on NISC. You see a user provided an explanation that recloser was under a hotline order, meaning it was configured. Let's say if it was a recloser, that hotline tag switch was set. So what hotline tag does, most of you probably know this. If it detects any hint of just the slightest period of time and overcurrent, being detected, it opens the breaker instantly. It disables any reclosing functionality, so it's immediately locked out at this point. So a weather system came in, something with the weather caused that that current to go over the minimum trip. It immediately knocked it out. In a scenario like this, typically it's a momentary outage where if you just close it back in, it's going to hold in and it's going to be just fine. And you'll see based on the comment there, it's closed in, it's holding, and it did stay closed in. So that's an explanation of what happened here. And just to point out again, you have the SCADA reporting the status of that breaker is open, then you have SCADA again reporting that status as closed. With that said, I just wanted to show you these things about NISC's OMS. Of course, we are also able to integrate with NISC. But the very last thing I'd like to talk to you guys about today is just one additional capability of our multi-speak integration. We have a couple customers that have implemented it and are implementing it. Is integration with a meter data management system, or MDMS. And to give a summary of what that is, basically it collects data. Typically it'll collect all the data together and analyze the data that comes in from AMI smart meters, and typically that'll be with an AMI system is what an MDM system is associated with. So similar to OMS, and this brings up a point, a meter data management system can be a standalone solution. There are a couple standalone vendors for an MDM system. It can also come packaged with an AMI system. So if you get the solution from your AMI, maybe when you're getting an AMI system, but if you wanted to take a look at some other sort of solution, you can get this kind of standalone solution that might, if you look at it, might be a better proposition than the software suite that the AMI vendor provides to you. By the same token, this is a point we make because we like promoting our Orion SCADA solution. The more full-blown SCADA, you do get all sorts of, you get a software suite with all sorts of tools, a pretty thorough, what I call a fully featured SCADA system. But it's worth noting here that there are some of the more useful tools on a full-blown SCADA system. The notable example for this webinar being the OMS. You can have standalone solutions for some of the more useful features of that SCADA system. So then what you end up having, of course, you have SCADA, you have Orion SCADA, and you can use means like you can use multi-speak to send data around to those additional solutions. And what you end up having is you can potentially have all the useful tools of a full-blown SCADA system, but just being able to pass the data between all these, these different solutions seamlessly through a solution like multi-speak. And then you don't have, let's say, the costs, or you don't have, all that associated with a full-blown SCADA system. You instead have all the usefulness through these standalone solutions. It's just something I guess I ask you to think about, that these solutions are available. You can get a lot of the functionality from a full-blown SCADA system, potentially at a lot less cost. So it's just an idea I wanted to plant into your heads, and of course, certainly do your own research to see if something like that's right for you. But back to the MDMS system, why pull in meter data? What are we pulling in if there's an AMI system out there? Well, typically we'll have meters in the substation, and those may not be a part of the AMI, but they're, of course, recording metering data at the substation. You can import that metering data from the subs. You can pull that into your MDM system. So that includes that improves analysis of the smart meters that you have out on the line. And it also improves the ability, as an MDM system is known for, the ability to protect or to detect issues with those AMI meters, including various things like electricity theft, meter tampering, the funny business that can go on with the meters on a system, or maybe meter failure. This is just extra data, metering data coming from the substation that would help with that kind of analysis. So it's worth mentioning, a lot of people find this to be a useful tool, this meter data management. And there is a standalone system out there that can communicate through multi-speak. And the last note, you saw our setup for OMS, setup, at least on the Orion side, for an MDM. Exactly the same. The only real difference is you're pulling meter data in instead of, say, breaker or protected device information. So with that said, guys, again, apologies, we're about 10 minutes long, but I hope you guys enjoyed this presentation. Let's see, I don't see that we have any questions coming in, guys, but so I can go ahead and bring it to a full close. Again, I appreciate your participation. I appreciate you guys sitting through this whole thing. I hope you found it useful. But we will include a note here at the close. Wanted to remind everyone about our customer community. That's our website, novatechautomation.com/community. On this customer community, you can get, just you can get an easy login to this site. You can see down here, you can sign up by clicking the button right here. So on this site, you'll have access to all sorts of documentation. You can get drawings, certifications. You can have our full suite of our trainings and our webinars. And the question we commonly get is this being recorded? Will this be available for viewing after the webinar? Yes, it'll be available on our customer community under the training and webinar section. You'll see in very front and center on the customer community are various means of getting immediate support with our products. You can call into our office. You can send kind of a support email. There's a support form you can fill out, or you can use the feature right here to book a call with an application engineer. And if you click into that, we'll come right back to that. You'll come up on this screen. You can actually set yourself an appointment. You can set a date, set a time, and then you can select a sales engineer that you would like to have a short meeting with. So you'll see the various names. This is the current list of sales engineers. You'll see myself, Brett. You'll see James Larson, and various others, including some Spanish speakers. So pretty much anything you need support-wise. If you select anyone, then the leader of our team will be able to pick the person that's best suited to you. So that's pretty useful. Or if there's someone you've been speaking with on that topic, you can feel free to select them from that list and continue the discussion. So guys, this is an exceptionally useful tool. I encourage you, if maybe you want to spend some one-to-one time to talk about either an issue or something you're looking to implement or a general question, use this tool. Lastly, our customer support site. Our customer support site is the place you go for information, really just NCD, the NCD installer. You can get our firmware updates, which we call distro version updates. So you get firmware, you can get release notes on those updates. There is a section called My Orions, where you can go and see a listing of the Orions that your utility has, or that they have purchased from us. And you have access to download the key files. And key files are basically just a list of the supported features on that particular Orion, and you can go load that to the Orion if you're needing to recover that key file. That's a way to do it. But again, very useful, the customer support site. And that is all I have for this presentation. Everyone, again, I appreciate you, and I'm sorry this ran a little bit long, but on the screen you'll see contact information for both myself and for James Larson, both on this webinar. And feel free to chat with us if you have any questions out of this webinar. And everyone have a great rest of your day. And once again, thank you.